Do you remember the first time you drove by yourself on a highway? Picture it, driving in the right lane, white-knuckled and locked at 100 kilometers an hour, terrified. You look to your left as an elderly woman passes your car. She must be driving faster than you, over 100 kilometers an hour. But all the same, it takes an excruciatingly long time for her to pass you and leave you in her dust, and your shame. How can someone traveling so fast seem to be going so slow? This example shows that the velocity of Grandma's car is a matter of perspective. It depends on the observer's frame of reference. We call this relative velocity, and would like to understand the connection between the different velocities in this situation. Let's start with a simple example. Suppose you want to impress your friends, showing them how fast you can swim. You can swim in still water at a certain speed, let's call it V pool. But today, you're going to swim down the Speed River. If the current in the Speed River is 2 meters per second, how fast will you appear to be swimming from the perspective of your friends on the shore? Your swim speed, as viewed from land, will be the sum of two contributing velocities, the speed at which you can swim in still water, plus the velocity of the water itself. We add these two vectors, lining them up tip to tail to get the result. So to your friends on shore, you'll tear by at 5 meters per second and appear much faster than you would have in a pool. What if you chose to swim against the current? The speeds haven't changed, but your efforts are now directed to the left. Let's call this the negative direction. What your friends observe is still going to be the vector sum of the two contributions. It's clear that you're not going to blow your friends' minds traveling at 1 meter per second to the left. In both situations, we can determine your velocity relative to the shore as the vector sum of two contributing velocities, your swimming efforts plus the velocity of the water. This same principle applies if you were trying to swim across the Speed River, perpendicular to the flow. If you direct your efforts upwards on the screen, the current will still contribute to your overall velocity. To determine your velocity relative to your friends, we need to invoke trig and Pythagorean theorem, but the same principle applies.